I'm here with Dr. Mykela DeLuca, who is a battery data scientist at Micantis. What is Micantis?
Micantis is a battery data analytics platform. It offers a lot of one-click analysis tools. EIS, HPPC, voltage versus capacity for many cells, really just helping customers with data accessibility.
So it stores all the data from potentiostats and cyclers in one spot, like a unified data management platform.
Exactly.
Wow.
It's really made to take the burden of data management, kind of having 20 different Excel sheets off of the customer so that they can actually focus on data analytics rather than managing the data themselves. This customer that is a very large manufacturer, they're also interested in things like cycle life prediction. We have these cells and we cycle them for hundreds and hundreds of cycles. Some of them fail and some of them pass. Can we cycle for 50 cycles or 100 cycles and know that it's going to fail hundreds of cycles in advance? And so I've been working with their old quality assurance data, old cycle life data, using the Micantis tool to compile that data, to clean that data very easily, start building models so that we can predict whether cells will fail and when they will fail.
Because it's so expensive to cycle cells for thousands of cycles. How do you even get the right data to inform that model?
Yeah, absolutely. I think it takes working really closely with the customer to understand how they're running their cycle tests, what they want out of the model, what kind of cells they're using. I also think it takes somebody with domain knowledge. I don't know if a data scientist with no battery knowledge would be able to build these very effective models.
What's your process you go through?
Yeah, when we have a customer that has a request like this for a predictive model, we'll work with them to understand what they want. We'll go to the Micantis platform, figure out how many cells they have. We will be able to know if, hey, can we even build a model? Do we have enough data? Other things that you need to build a model is a certain amount of cells that pass and a certain amount of cells that fail. If all of your cells pass, you're not going to have any negative training data. And so our customers can enter specifications in Micantis, but that's basically what we call pass-fail metric. And I can easily access that through the platform again. So I can quickly see, 500 cells passed and 300 cells failed, and we have 800 cells total. So this is a good candidate for a model.
Does Micantis have any tools to make sure that the data is pristine and ready for that next step of advanced analytics and modeling?
Data can often be noisy, and sometimes noise can inform features. And sometimes noise is just noise from cycle testers. And so you need somebody who is familiar with cycle testing and battery data to be able to effectively figure out what's what and clean that data. The other thing is that cycling data can often be messy for other reasons. So if you have a cycle tester that fails unexpectedly during cycling, for example, oftentimes you can get two different files from the same cycle life test. And so you can't train a model on fragmented data. So you have to stitch it, which can be very tedious if you're doing it by hand. But Micantis has an internal tool where you can just quickly search your files, see which ones need to be paired up, press maybe 3 buttons, and then they're stitched and aligned on test time, cycle number, the capacities, the energies are all aligned with each other and match up. Yeah, for one customer project, I had to stitch on the order of 150 to 200 files because they had lots of data. And it took me maybe less than half an hour to do it.
No.
Yeah.
Oh my gosh, that's insane.
Once you have clean data, there's a few steps and they all iterate with each other. And the first thing is feature extraction. You need to extract features that might describe the failure process that you're seeing. So maybe voltage-based features, if you're running any type of DCIR during testing, extracting those parameters. So you'll extract your features for each cell and each cycle, and you'll train a model. Training a model means putting that data into a model. Models have parameters talking about things like how normalized is the data and how much weight do you give to features that have no importance. And so you'll tune the hyperparameters of your model and you'll get results that talk about precision and accuracy. So how many cells did we correctly predict failed at a certain time point?
Wow. So it actually gives you the accuracy of the model itself.
Yeah, so then you will put cells that your model hasn't seen before into the model. And what you can get is essentially a probability at each cycle that the cell will fail, or what the failure cycle will be for that cell with every new cycle, and have the model update at every new cycle.